All right, so I am going to assume that you can hear me and see everything. I think Matt's got that all figured out. So let me just say first, thank you to Mechatronic Solutions for giving me this opportunity to spend a little time with you all this morning. Obviously, I would have hoped to have been present with you all, but it just didn't work out that way. So that's okay. So I've been allotted 75 minutes, but I don't think I'm really going to go anywhere near that long. Hopefully, I go a little longer than my brackets have lasted through the NCAA tournament. But what I want to do is just kind of take some time this morning to talk about what I'm calling the collaborative storyline. And kind of go through that in a way that is what's the experience kind of that I've seen since we've launched collaborative robots and kind of what the experience has been with customers. What have we seen? What are we seeing? And kind of what do we expect to see? And then just kind of touch at the end really about for you all as you look at using collaborative robots and trying to justify it up to your executives to get finances to invest in these things. How do we even go about that? So I'll just kind of quickly touch on some of that. So um, just so you know, since Matt is muted for this, Matt, I do have my chat screen open. So if there are any questions that you want to throw into that, I'll be able to see that. So that should be clear enough, I think. All right. So let me first talk about something called cynic theory. And what I'm going to do is kind of take a step back, give a little bit of background on kind of the how I think we got to the collaborative robots at all, and then kind of launch more into the specifics of talking about collaboratives. Um, so first, cynic theory is something that our founder, Omron's founder, Kazuma Tadaishi, put together. He released this back in 1970, and it's really a theory to try and explain how science, technology, society, and everything really interplay with one another. That there's this kind of cycle that develops and launches where science comes up with some sort of technology discovery, and then technology takes that discovery, finds a way to apply it, and then delivers it as a product or solution to society. Then society uses it, plays with it, develops new needs or new questions that need to be asked. So society goes back to technology and says, well, I want something new. And so technology needs to work to find new products, new solutions. But in order to do that, what they actually need is for science to actually come up with new discoveries. And it's this cycle of a seed discovery, then technology taking that and innovating it into a solution, then society using that, developing a new need, and then technology saying, with that new need, we have this impetus for new scientific discoveries. And we call that the cynic theory. And why that matters is because as we look over the history of time and we kind of see these different technology developments and scientific developments, there's a pattern, or not really a pattern, but more a trajectory that we've seen. And this is something that Tadaishi put together again back in 1970. And he's kind of looking out towards the future at that point in time, which is even 50 years ahead, which takes us to right about now. And he's looking at these different societies that are going to come into play, and how does the technology that's available at the time really support what we're trying to do in society, and how do all those things interplay. And really, what we're trying to get to is understanding that row at the bottom, which is what's the interplay between humans and machines. That if we go back to pre industrial revolutions, really there was no sort of machinery involved. It was just humans doing the work kind of manually. Then we get to the industrial revolution, and what are we seeing? We're seeing automation, and we're seeing machinery really just replace humans, right? The goal is to get the person out of the process so that we can gain efficiency, we can gain quality, we can gain throughput, all of that sort of stuff, right? That's what we're really wanting to accomplish, is to use that technology to eliminate people. But then there's ebbs and flows where that was what we were first doing, but now then as technology continued to grow and people needed to get back somewhat into the process of manufacturing, is now we have humans cooperating with machines, where it's not just eliminate people, it's more how can we have people working alongside machines so that the two can really identify what do they do best, what do humans do best, and how does that work together. Then the long term goal, really kind of that end game is that bottom section where it says harmonize. So machines enhance the capabilities of humans. That we're taking a human, we're taking a machine, we're putting them together, not in some sort of like cybernetic thing, but that we're taking them and that we're allowing them to work really not just alongside one another, but with each other to maximize whatever sort of thing that we're trying to accomplish in our production environment. And so it's this whole idea that Tadaishi had where he said, to the machine, the work of the machine, to man, the thrill of further creation. And what we're saying here is that when we look at tasks in sort or in a production environment, there are a lot of tasks that really can just be handled by machinery, right? They don't require uh, a lot of human value input to them. There's nothing value add that a human may add into certain aspects of a process. But at the same time, what we as people do provide is we provide insights, we provide creativity, we provide new ideas, trying to link different things together. So really, what we want to do is try and identify what are the tasks that should be done for machinery, and what are the tasks that should be done for humans. And when we talk about robotics, one of the best ways I've heard to describe where to apply any robot is in applications that are dull, dirty, or dangerous, right? If it's a dull, monotonous type of task, that's a great place for a robot because, as we all know, people get tired and lose focus, but robots never get tired and they're not going to lose focus. They can do that same task repeatedly over and over again. Dirty, if it's a dirty environment, certain types of robots are more suited for that than others. But if there's, caustic or hazardous materials and airborne pathogens, that sort of stuff, you don't want people in that environment. And then lastly is dangerous, right? If we're having something that is really, really hot or spinning knives or anything like that, that's an environment, again, that we don't want people. We want to put some sort of automation in there. But it's really that dull part that we tend to look at most when we talk about collaborative applications. So if we zoom back a little bit, I'm a child of the 1980s, so my first exposure to robots was really R2D2 and Rosie from the Jetsons, right? And this whole idea of when we first started thinking about robots and dreaming up robots, we dreamed them up to do the tasks that we don't want to do, whether it's the housekeeping tasks or to be able to interpret between different languages, different types of tasks that we thought that robots could do. And if you look at any sort of depiction of a robot from any sort of pop culture, what's one thing you don't see in any of it? It's safety. We don't see safety because the assumption is always that robots are somehow going to be operating alongside humans. And that's really kind of that end game again. That right now we have robots and we have them behind gates and fences and all this sort of stuff. But ultimately, when we think about going to that cycle again of that cynic theory, when we think about what we want a robot to really ultimately become, it's a robot that operates alongside of us in a completely safe manner. And that it's really imagination driven. It's what our minds have conjured up as what a robot should be, and that what a robot could potentially do. And obviously, these tend to be more of our day to day life living experiences with robots. But really, this is the same thing that as we look even into the manufacturing environment, we dream of a world where robots can be operating alongside people in the same space. So, as we look at kind of the storyline again of how collaborative robots have come up, there's an idea in movies that's called the 7 basic plots. And essentially it says if you look at any movie, any story, there's really only 7 types of plots in all these different stories. And I would say that when we look at technology and automation enhancements, there's really one typical plot that we see in how technology gets introduced and adapted and kind of used over its lifetime. And so that's how I want to look at collaboratives. And that's why I'm calling this the collaborative storyline. That the first thing is we're going to talk about the past. And the past was really all about experimenting with collaborative robots. And so when I talk about past, I basically mean from let's say 2010 to 2020. Um, then we're going to talk about the present, and that in kind of the immediate years previous to now, and the a couple of years after this, it's really about evolving our understanding of collaborative robots. And then lastly, as we look to the future, it's really about expanding the impact of collaborative robots, where we see them, how we see them used, what's the full maximum benefit that we can really get out of collaborative robots. So first, let's talk about the past. And what I want to propose is that, in my experience dealing with customers as we began launching collaborative robots and working with different people, that there were really three different types of people or three different types of customers that we dealt with. We dealt with what I'm calling technophiles, visionaries, and people that were just at the right place at the right time. So first, technophiles. These are the kind of customers you love to go to because they're the ones that want to see the latest and greatest, right? They are individuals that want to try and use a collaborative robot or any new technology for whatever means they can to try and shoehorn it in because they want that application. They want that new technology on their floor. And we saw this a lot right out of the gate. And really, there were some shortcomings, I think, that we found from this type of customer. First thing is collaborative robot versus application. And the picture there, it shows a robot with a knife at the end of it. And when we take a step back, we know that if you take a knife and you put it on the end of a robot, it is no longer a safe robot, right? And so there was this constant talking and coaching that we had to do with customers to recognize that a robot itself is not what's collaborative. The collaborative side of it's really the application, that you have to look bigger beyond just the individual robot. Just taking an application that had a 6-axis robot in it, throwing a collaborative in it, does not inherently make it collaborative. It has to be collaborative depending on the tools used, depending on the safety setup involved, what's the overlap with the people that are in it. And so oftentimes this was stuff that wasn't being brought into account. We actually had a customer that was using, they were injecting molded plastic pieces. And what they wanted to do was they needed to do a knurled press, like a heat set, to push into the injection molding. And they thought if they used a collaborative robot, it would make it safe. Well, obviously, the pieces that were getting heat set had to be heated up to an extremely hot temperature, which again, by default, is going to make that an unsafe application. So it was really a misapplication of a collaborative robot because inherently it wasn't a robot that could even be, or an application really, that could ever be safe just based off of what they were trying to accomplish. A lot of this silver bullet mentality where they just think if I throw a new technology in, I'm fixing my problem because I'm at the latest and greatest edge of the curve of technology. And that's never the case, right? It always takes a bigger mindset to understand how to really address problems that are more process oriented than just throwing in a new piece of technology. As I mentioned, they ignored the broader process. So not just thinking about their entire line or how their entire process flowed, they would take a collaborative, put it in a very simple place, and again, have this mindset that they can fix things just if they put the robot as a fix in one location. And then a lot of them began to understand that there are trade-offs with fixed industrial robots. And I'll mention this in a slide later, but essentially you are giving things up when you go to a collaborative. So you have to understand, when does it make sense versus when does it not make sense to use a collaborative versus a fixed. So that was the technophile. Next thing we'd run into visionaries. And why I called them visionaries is because you had the sense that when we would introduce the robot, they weren't just looking at the technology, but they really had a broader strategic approach within their organization of how they were going to use this technology to really enhance what they were trying to do overall as an organization. They had plans to realign factory flows, to reallocate where resources were going to be located. They had a long term strategy. And I can say this customer because they used to be part of our family, but Omron Automotive. So, Omron Automotive actually bought several different collaborative robots from us. And when they did that, they didn't just they bought one to put in a lab to test to see how it worked with. But really what they did is they had a team that they call their Kaizen team. And their Kaizen team basically looks at the overall flow of the organization, the different manufacturing lines, and they're constantly trying to identify how do they improve uh, processes, quality, etc. And so their whole approach was they picked off about 3 or 4 highly strategic projects, and they saw where the collaborative made sense to use it in those applications. And they recognized that, again, it wasn't just a one off thing to try and shoehorn in, but that it really fit into this broader approach. And a big part of it, too, is they understood how users were going to interact with the robots. They understood at times that the robot would be on its own. They thought about almost sequencing out what the production process looked like so that they could figure out where was a person involved, where was a person not involved, and what needed to happen at every step of the way. They did all the work ahead of time and thought through it ahead of time so that really the collaborative robot selection was just about finding the right tool to accomplish something that was already bigger. So that's the visionary. And then we ran into people that were just right place, right time. Um, they had an opportunity. They were going to be updating a line, they were building a new machine, whatever it was, and they just had a decision they needed to make about putting a robot into an application. And so some of them were trying to decide maybe we should go for a collaborative, try this out, see how this works. And they used that as an opportunity to put it in and play with the technology and learn it and understand it. We also saw it be very necessity driven. Obviously, going through the Great Resignation and all the employment issues that we had, they found that as an opportunity to basically plug robots in where it made sense to try and deal with adaptations and number of employees that were going to be available anytime on the line. They liked it because it was easy to use. One thing that collaboratives have and that they're really designed for is to be incredibly easy to use. So they're fast to learn and they really are pretty fast to implement because you're not typically having to build the same size of cell that you are with a fixed robot. With the collaborative, you can put it on a cart, you can roll it up, lock it down, whatever you need to do, and then you can have it run the application. So people like that too because they felt they didn't need to go to some sort of outside integration company, that they could learn it and understand it inside, and that worked well for them. And then we also had situations where they liked that it was lower risk. And lower risk meaning that when it came to the application type, they could use it for some application that they had it intended for. But if they found out it wasn't really a great fit for that, cobots are really adaptable to being reused and repurposed. So for them, it made sense. Okay. So we had the technophiles, the visionaries, and then the people that just happened to be in the right place at the right time. And those are really, again, that was the past that we saw, that it was a lot of experimenting, kind of figuring out what did it look like to have a cobot in your application, and sometimes recognizing the trade-offs of things that they were giving up by having a cobot instead of having a fixed industrial. So now, what about the present? And the present, we're evolving our understanding. And one resource I would point you to is this book, Lean Robotics. This was written by Samuel Bouchard, who's the CEO of Robotique. And it really isn't about any particular product. This is really about understanding how to bring a robotic application into your factory. It's looking at what are the interactions of the robot with the supply side and the downstream side and the people, and what does a maintenance plan look like, and how do you work on adapting it to introduce the technology to people so that they feel comfortable with it when it gets introduced. And I think what we're starting to see as we're gaining more and more experience with collaboratives and customers are gaining more and more experience with collaboratives is that, again, you have to take this bigger, broader approach if you really want to be successful at applying the technology in your environment. So, again, I would highly recommend this because it just gives you a framework for being successful at the entire installation and the entire application. Okay. So, how are we evolving? Well, now we're really starting to gain experience. It's all about experience that we're seeing again what works, what doesn't, and it's kind of refining how we go about using these applications. And we'll talk about also kind of a little bit of a dichotomy between user types that we see now with collaboratives. So first, industrials. Are they the protagonist or are they the antagonist in the story? And I would say it's neither. It's always about selecting the right tool for the job. So over there on the right, you can see it's a chart basically showing sales breakdown by fixed robots and collaborative robots. And obviously you can see fixed are the blue line. That is by and large, a much larger portion of the types of robots that are being used. But if you also look at the red, you will see that it is an exponential growth curve. Even though it's small still, it's an exponential growth curve that we're seeing in the use of collaboratives. So you can see from 2023 to 2030, the predicted CAGR is 29.9%. So we're expecting to see that market of collaborative robots go 30% year over year through the year 2030. There are some other charts that I've got on another file that show really what that looks like, and it's an astounding view to see that. So collaboratives make sense in certain places. Fixed robots are still going to make sense in other places. So where do we select fixed over collaborative? Well, if you need speed, fixed robots, they are stiffer, they're more dynamic by nature since they don't necessarily need to adapt to how people are responding and interacting with it. So they're always going to be faster. They're also going to have higher repeatability. They can just be more accurate to a repeatable number anytime that we need to do that. Load, typically they can handle larger loads. Now, I think we're seeing collaborative load sizes continue to grow, but by and large, fixed robots are always going to have a higher load capacity. Single purpose. So if you can design an application for a robot and you can leave it there for 20 years, fantastic. Maybe not even 20, maybe 5 to 10. That it just does really well with giving it a particular task and you don't really have a need to repurpose it in a dynamic environment. If it's separated from employees, right? If the application is behind gates or it's going to be inside of another machine frame where people aren't really engaging with it, there's no reason to go with a collaborative. Just use the fixed industrial at that point. And then lastly is unsafe applications. We had a customer that wanted to put a welding tip at the end of a collaborative. I think pretty obvious. That's not really a safe application. So in that case, the fixed industrial robot is always going to be the best choice for that. So again, protagonist, antagonist, it's not one or the other in terms of one's right, one's wrong. It's identifying what do you need in your application and which is the right tool to accomplish what it is that you want to do. So as we, though, continue to grow and continue this evolving, we're starting to understand a little bit that how we interact with the robots, there's kind of a spectrum of what that should look like. So first we have coexistence, where the workspace isn't shared, there's no direct contact, and the tasks that a human and a robot are doing aren't really related. So think of this as if you have a machine tending application, you have a robot that's attending one machine here, and then you have a person that's attending a different machine over on the other side. The person is basically staying out of the exact operating space of the robot. So by nature, it's really not a super safe requirement, but it allows you to take down the guarding and some of those benefits. Now you get to synchronization. This is where we start to see a little bit more overlap. So now we're saying that the workspace between the person and the robot are the same. So where a person is going, they may be walking through the range of reach of the robot, or maybe there is um, a situation where a machine is unloading parts onto a pallet and the person walks up, grabs the pallet or tray, and that they're grabbing it and moving off so that the person is going to be inside that space. We would call that synchronization, where you're kind of just there's a dance going back and forth between the person being in the robot space and the robot waiting for the person, and vice versa. Then we go up to cooperation. Again, now we're changing into a case where the robot and the person can be directly touching one another. Think of basically loading parts into a fixture or tooling that's at the end of the robot. So instead of having some sort of automatic feed, maybe a person needs to come and actually put something on the robot. Now the robot and the person are in direct contact. And so now we have to look at it differently. But we're saying that these tasks, we're calling them sequential tasks, meaning that there may be an interaction between the person and the robot, but the robot goes off and does its thing. And then when it's done, the person grabs the part and then the person goes off and does their thing. Then the highest form is what we're calling collaboration. In collaboration, if you think of it this way, think of it as a robot on one side and a person on the other, and the person is doing tasks on a part that the robot is holding. So maybe the robot is holding and moving a part into certain positions, and then the person can actually go and do some sort of assembly task, for instance. So we have this coexistence, synchronization, cooperation, and collaboration. And these are all spectrums, again, of what really is required out of an application. And where we tend to see most people sitting right now is just that coexistence and synchronization, right? Cooperation and collaboration, we don't really see a whole lot of that. And I think it's because there's a lot more involved in the actual background work and planning of that. So we're also understanding where specifically does it make sense to put a collaborative robot. And there's this technique called the lotus blossom technique, and it's really just if you think of a mind map where you sit down and you say, what's our central idea, and you come up with a bunch of ideas off of that central idea, and on and on and on. And there was an institute in Europe that worked with several different machine manufacturers and integrators to do this idea, but with collaborative robot applications. And so the way they went about doing this is they said, let's look first at applications. And when we say applications, we really mean tasks. So what tasks are suitable to automate by a collaborative robot? And you can see, for instance, over on the right side, you've got assembly, inspection, kitting, joining, final assembly, packing, pick and place. These were all a bunch of different ideas that they came up with. Then the next thing that they said for each of those, they said, well, what about application areas? So where would we do pick and place? Where would we do kitting? Where would we do inspection? And then they kind of branched that off into a larger subset of ideas. And then the other thing that they factored in as well was, what are the KPIs? So how do we actually measure that a cobot is really doing what we want it to do? And there are several ways that we can go about doing that. You can look in terms of ergonomics. You can look in terms of personnel, hours, throughput, et cetera. There's a range of different things you can do. And ultimately what they came down to is they tried to measure impact. And impact is really the importance of a particular task within a factory, and then the payback time. How fast can they get that robot up and running, and how fast can it actually do what it wants to do? And when they looked at those two combined, they measured what they came up as these impact. And so what they found were the most high impact applications for collaborative robots right now are loading and unloading, which is machine tending, and inspection tasks. So really using some sort of camera, because oftentimes collaboratives will have a camera mounted on the end of them, or you can put a camera on the end of it, as well as different measurement sensors and whatnot. And that these were just tasks that were really well fit for a collaborative. And a few different factors came into that. One, it was that coexistence and synchronized workspaces, right? That we're not doing this cooperation or collaboration where the person is really involved with the robot end of arm tooling, but that a person may drop a part in to be inspected and the collaborative robot does that, and then it's off to the next thing. So it was a low you're really just kind of putting the robot in there, and you're able to kind of keep the people out of it still. Minimal change to overall process. So they're really, again, like I mentioned, ideally you're looking at the overall flow, but as people are trying to just get collaboratives in, get quick wins, they are looking at some of these narrower tasks. So something like machine tending is an easy thing where you can put a collaborative in, but you don't have to redesign your entire factory flow or your entire process flow. You can really just put the robot in front of that machine and let it do the task that it needs to do. And then they're quick results. Again, we're not having to reconfigure much. We're not having to change and do significant investments. With a little bit of tooling, thought through part flow in and part flow out, you can really have a machine tending application up and running. So these are things that really do help make good sense when trying to come up with these applications. So what are we seeing? And I don't apologize, I wasn't there, so I don't know exactly what was talked about, but I do just want to hit on a couple things with the Omron TM collaborative robots, is that how we're kind of adapting as we're evolving is we're adding these new safety features, we're making easier programming, and then the flexibility of installation and operation. So we're trying to make these stand alone. We're trying to make these quick and easy to implement. And one of the things that we've done now on the newer series of Omron TM robots is we've added a lot of additional safety features directly on the robot itself. So from an installation standpoint, you don't necessarily need to have safety relays and inputs and whatnot if you need to do a small standalone application. The TMS actually allows you to take a variety of different safety devices and direct hardwire them to the robot for managing a variety of different types of e-stops and safety configurations. So there's 31 new safety functions. There's easy in terms of transferring safety settings from one robot to another. So this is a good thing that if you are going to be scaling up how you are using these and you have one robot that's set well, you can easily export all the safety settings over to another device. And we also have, and this has been honestly in TM Flow for a while, but it's a safety guidance worksheet that's in there. So essentially what you do is you look and you figure out where would a robot potentially come in contact with a worker, and based on that, it kind of tells you what the speeds are that make sense for it to operate at. Okay. Then we're also kind of looking at different user types. And by that, I mean, there are two types of people that we tend to see heavily when we look at collaborative robots. We see the programmers and the non-programmers. So for the non-programmers, they really like collaboratives because it's flowchart-based programming. It's easy to work with. You can grab the free button on the end of the robot, move it into position, hit point, it'll record the point. And then you can just add a few things. And you don't have to be an expert programmer to understand how to set one of these up. Now, is there some knowledge required? Absolutely. But it's not a text-based programming that scare a lot of people away. So in some ways, we're taking the technology and we're making it very accessible to people that are maybe intimidated by traditional programming languages. But then on the other side of it, we have cases where more traditional programmers don't like working with the workflow interface or the flowchart interface because they want to see more traditional programming. And so for that, what we've done is we've launched now a script programming language. So it gives users the opportunity to write in either script language if they're a programmer and they want full control of everything, or they can put it in flowchart if they want to keep it simple, easy to use, and easy to understand. So it just makes it very nice to work with. And we get to the best benefit of all is that you can actually write subroutines in script language that you can then bring into the flowchart. So you could do some complex programming, but then combine that down into a simple subroutine that somebody who's not an advanced user can just use as kind of a black box flow node of code that they could operate with. And so we're trying to recognize that, again, there are people that are using it for its ease of use, taking and replacing an industrial robot just because it's easy to use, but then also recognizing that more and more capable programmers are using it. And for that, we need to get out of just doing the flowchart because they want to have more control. And another big thing is the landmark. I'm pretty sure you would have seen some sort of demonstration with the landmark tool, but what the landmark tool allows us to do is use the graphic, that tab piece right there, put it anywhere on a machine or on a pallet or anything like that, and adjust our reference frames so that we can adjust our parts and all of our points in 3D space to whatever this new reference frame is. And that allows you to move a robot around. It allows you to adapt to slight inconsistencies in pallet drop-off location, or if you're putting it on a MoMA, which is a mobile manipulator, which is really just a mobile robot with a collaborative robot on top of it. As you drive around, it just continues to realign all of its points when it gets to whatever its destination is. And this is a great tool. This is probably one of the most important selling features of a collaborative robot, is that it is very dynamic and very adaptable to changes in the environment. So as the mounting location changes from day to day, or again, if the part presentation and part outflow are slightly different, these robots can adapt to it. And it's a real easy setup inside TM Flow. TM Flow does a really nice job making that easy to use. And it's free with everything that you get. So there's not an additional license or anything that you need. It's just part of the system. And that's, yeah, I guess I kind of spoke through that, but it's really allowing for easy location or relocation, right? So that you can just move the robot around as needed, reshoot the landmark, adjust, and then do whatever the tasks are from that point. All right. So we talked about the past. We talked about evolving through the present. And last, let's talk about the future and the expansion, right? So we're going to see continued developments in what we have with collaborative robots. So we'll see portfolio expansion. We're going to see adaptive robots and then embodied AI. So with portfolio expansion, I think it's pretty obvious, as time goes on, all companies are trying to add more features into what it is that they offer, trying to add more size, trying to add more capabilities. That's going to be those small improvements that we continue to see over time. Okay. But one of the things that we really want to move towards is, eventually, and this is not something that's coming tomorrow, but it's this concept of embodied AI. So when we take AI and we put it into a physical system, think mainly a robot, that's when we get what we call embodied AI. So that with a mobile robot, right now, mobile robots are doing, I wouldn't really call it AI as much as it is, they're calculating what they're doing, and they're calculating maps and looking at maps. So there is some extent of AI that's happening there. But what we really ultimately want to get to is a case where a collaborative robot can really be adaptive to the world around it, that it can learn, that it can understand what it's trying to accomplish and just figure things out on its own. So in one sense, the programming capabilities and the computing capabilities of the collaborative robot go up significantly, whereas on the other side, the user's involvement and the user's experience in programming it should actually get simpler in time. That's the holy grail anyways. All right, so I'm going to show a couple slides that I stole from Mark Noshang, one of our robotics engineers. Stole from one of his presentations. And that's really that ultimately what are we trying to do is we're trying to get to this harmony between people and machine, right? That's what I showed way back at the beginning, that we go through that cycle of cynic, that we're trying to get to a point where humans and people are really trying to be tightly harmonized in what it is that they're doing. And you can see we kind of have these big swings over time where we do mass manual production, and then we go way up to mass automated production lines. And then we say, well, we got to adapt to that. We got to bring it back to lean. And now we're going to collaborative. And you can see it's kind of this iterative process. And that ultimately we're trying to get to this autonomous and collaborative environment. And there's a few things that it does. When we look at production, again, we were looking at mass production. You have some sort of production line, you put it on, you make 1 million parts, you do everything through economies of scale. And more, what we're working towards is the idea of lot size of one, or mass customization, that we're no longer trying to produce 1,000 of the exact same widget, but now we're trying to say customers can dial in exactly what they want in their particular widget, and that our factory floor can create that particular part for that particular customer. It's really how we see things come off vehicle production lines right now, right? That you order a car, if you have the forethought to order it years in advance or 6 months in advance, you can list out all your options. And when that car comes out, it's coming out with a work production order that has all the specific options that you have. And that factory line is capable of providing mass production, and that it's churning out hundreds of cars per day, thousands of cars per day, but that it's producing that exact car that you want on the same line as other cars that have completely different option sets. And what we're tending to see is that, again, there's this convergence that's happening, that the disharmony between man and machine is moving closer to the worker upskilling. So we need to get workers that are capable of working alongside robots. It's a different environment when you are kind of working closely in the environment with a robot, and need to think process improvement about how to work alongside a robot, and that we're reducing that disharmony between man and machine. So what do we want to do? We want to allow people to redeploy, reconfigure robots as it makes sense in their environment. It's really about trying to make that flexibility on the factory floor. We want knowledge transfer. That's a big thing right now, is getting the knowledge transfer out of the aging workforce to the younger generation. We need to try and pull that out. And again, it's going to be process knowledge that we need to get, because the automation is going to be completely different in 5-10 years than what they're working on. But the more and more that they understand the actual process of manufacturing and what they're trying to do inside their factory floor, that's all the better that they need. So a couple different things. Let me show you just a couple videos to point out. I don't know how well this is going to come across. It's probably coming across a little bit choppy. But this is a graphic kind of showing an idea of what that future workflow environment would look like. And you can see there's a lot of mobile robots. I mean, when we talk about collaborative, often we're talking about the 6-axis collaborative, but a mobile robot is collaborative as well. So we're trying to merge really an environment that's completely flexible and can use mobile robots to transport parts around, to do different functions in terms of picking and placing of parts off of a robot, and mixing also as well with fixed robots that are doing some type of fixed type of activity where it makes sense for them to do that. Okay, I'm going to jump forward to the next thing. And again, that whole to the machine, the work of the machine, to man, the thrill of further creation. That's ultimately what we want to do, is we want to take people and we want to not have them just doing that dull work, the monotonous work, but we really want them to create more and understand how can they come up with different ideas of how processes can flow, or how can they take their knowledge to the next level and make their jobs more rewarding. So it really comes down to, we look at collaborative robots as a way to enrich the types of activities that people are doing. This is a robot or a customer that is they make dental equipment over in Sweden, and I'll just kind of bounce through it. I don't know if I can actually. Essentially what they're looking at, though, is they're taking that broad approach really of understanding, again, how do the robots overall fit into their system of what they are trying to do. They're not just looking at a small piece. They're really seeing what's the overall impact they can change a production environment with. And then lastly, what we're seeing is what we call our MoMA. And I mentioned it earlier. It's a mobile manipulator. It's really it's a collaborative robot on top of a mobile robot. So that instead of having a 7th axis where you slide a robot back and forth, now you can move a collaborative robot in all sorts of different directions and have it work across the plant, take parts from one machine to another, and have it be safer, because you're not having to deal with conveyors and whatnot. I don't know if anybody saw recently, there was an article about a worker, I think it was in Florida, and she had dropped something next to a conveyor, reached in, got caught by the conveyor, and actually got pulled, and she was killed, unfortunately, in the accident. And so when we look at things like mobiles, if we can eliminate more and more conveyors where it makes sense, it's really a safety benefit as well, because now we're not just moving parts around, but we're also moving parts around without where places for people to potentially get injured. So, technology trends, what are we seeing? It's all about collaborative and mobile. That's the big changes that we see. We're going to continue to see more, as I mentioned with the embodied AI, that we're going to see more and more edge AI. We expect to see different developments within robots as we move into the coming future. And then IoT is a big part as well, right? Anywhere you can get more and more data up to your factory management system, it's just better to have more data that you can work with. Okay. So we talked about the past, experimenting with collaborative robots, that the present is really we're evolving and growing in our understanding of the applications and the technology. And then the future is really ultimately about expanding the impact of collaborative robots, how they can be used, moving towards that autonomous environment. But what about now? So what do we do with now? And I just want to give you a few takeaways here that will hopefully be beneficial for you all. But number one, start small. Look for those high impact applications, right? Applications where you could have a robot working next to people, but there's not direct involvement. As we mentioned back at the beginning, that study saw machine tending and inspection as two really good types of opportunities. Look for the quick return and find out how you can really measure what your ROI is. And it doesn't have to be just financial, but we need to understand what that ROI is and create metrics that you can have. And then leverage the IoT capabilities. Everybody wants a more connected floor. And the TM robots, our collaboratives, they have plenty of connectivity on it and a lot of data that you can pull out of there. So those are all different types of data that we can feed up. Train your operators. Anytime you're introducing new robots in, there's always a fear by operators, right? A fear that their job is going to be taken, or that there's going to be, ulterior motives and why the robot is there. But we want to try and sell to people how the collaborative robots are really beneficial for them as individuals, and show them how we can make and how they can work with the robots, both to not just physically do their work, but also to come up with ideas to make the process more efficient. We really want to empower people that are working alongside them. And then as you're trying to decide on these investments and move up, you really need to be able to sell to your executives. And whenever we talk about selling, it's even internally, it's really all about putting yourself in the mind of your customer. And in this case, your customer is the executives. And you need to understand what is it that's ultimately driving the decision making that they're trying to put into place, right? Is it a certain financial metric? Is it a quality metric? Are they trying to have other types of initiatives? And how does that feed into what they want to do? I think a lot of times when engineers try and sell new technology, they sell it by the ways that make sense to them, rather than thinking more and more about how to get into that executive's mind. So think bigger, but think about what their decision making is. And then as part of that, look through what are those benefits to the company, because the company benefits aren't just to the company itself. There are financial benefits, and that's obviously the way accountants want to track success of an investment. But there is value to customers. There might be value in more knowledge that they have about the production process, or that there's better quality, or whatever it is. That by freeing up a person to do a different task, now there's another value add thing that can be done for the customer. And then also for the employees, like we've been mentioning about training the operators, that there is a certain amount of enrichment that comes from working alongside robots. So that is the collaborative storyline. The past, that we experimented a lot, the future, or sorry, the present, that we're evolving, and then the future that we look to expand into whatever is next. So that is what I have for you. I told you I'd be less than 75 minutes.